Hey Lizzie, I have your most recent quiz here. So the first question that you missed was question 2. It says the table below shows the number of color pages a printer prints out over a period of time. So then in the table you can see that top row is the X or time in minutes, and the bottom row is the Y number of pages. So this question is, what is the constant of variation? Remember, with constant of variation, we always do y divided by x. So using any value in this table, we're doing the bottom row divided by the top row. So whether you do 3 over 2 or 9 over 6, all the way down this table, you can see that all of these fractions are equivalent. You always want to give your answer reduced, so I try to teach students to use the numbers from the smaller numbers from the table. So it's y over x, which is 3 over 2, and it looks like you maybe did x over y. Question 3 is asking which has the greatest constant of variation. So I'm going to have to do some work on A and B and then scroll down to C and D. So again, it's asking about the constant of variation. In these proportional relationships, it doesn't matter which ordered pairs you pick. So I always, again, try to start with those smaller numbers. So I'm going to do 20 divided by 8, 3.2 divided by 1, so 20 over 8. I'm going to grab my calculator. 2 point something. 2.5. And 3.2 over 1 is just 3.2. So right now, Table B has a greater constant of variation than Table A, but we do need to keep working in the next two. So I'm just going to remember this number, 3.2. Now we're going to go to the graphs. So when you have a graph, again, you just find one of the ordered pairs, and we're going to label it. So that's x is 3, y is 1. So that ordered pair is 3, 1. And on this graph, this ordered pair is 1, 2. So again, I should be doing y over x. So that ordered pair is going to be 1 over 3, which is 0.6. Remember, table B was 3.2. And in graph D, y over x is, I don't know what happened there, 2 over 1, which is 2. That's also less than 3.2. So table B had the greatest constant of variation at 3.2. And so then that is correct there. Question 5 says, Caleb made the table below to show the number of hours he works and the amounts he earns over a 4-week period, which describes whether the relationship between the earnings and the number of hours represents a direct variation. So in order for there to be a direct variation, every time you divide the y over the x, you should get the same constant of variation. Constant, the word constant means like the same. So if the constant of variation is the same all the way through the table, then you have a proportional relationship, or direct variation is the terminology they're using here. So you just start checking. What's 140? Again, notice it's always y over x. 140 over 12, 170 over 15, 200 over 18, and 230 over 21. And I'm just grabbing my calculator. I don't even know if any of this goes in evenly. 140 divided by 12 is 11.6 repeating. 170 divided by 15 is 11.3 repeating. So you can already see that there is not a constant of variation. So there's no direct variation here. 200 over 18, if I just keep checking, 11.1, 230 divided by 21. And again, if the question were just, is this a direct variation, you could have stopped right away. I don't know if that one repeats. I don't think it does. Yeah, it does eventually. But 10.95 continues on. But you can see that it's not, none of these are the same. So he earns 20 more then 10 times the number of hours he works. 120 plus 10, 150 plus 20, 180. Well, that's true. But the word more than, that's addition. And remember, in these constant direct variation equations are in this form, y equals kx. This is multiplication. So this wouldn't be, this equation, this is saying that 10 times more than the hours he works, 20 more than that. There's addition there, so that won't work. The earnings increase 30 for every increase of 3 hours. So you're not looking this way. That's, let's see, what are we adding there? Adding 3, and here we're adding 30. Adding 3, and here we're adding 30. So basically this means you make $10 an hour. That's the slope. So functions that are relationships that are not direct variation can still be straight lines. So this is one of those cases where if I were to graph this, we're starting up here. I still might have a straight line, but we start up here. Remember, these direct variation types of problems, they all actually go through the origin. So even though we're adding 3 to the y or the x and adding 30 to the y all the way down the table, that doesn't matter because that just means it's linear. What we actually have to check is this ratio here, which is all this division that I did down in this part. The ratio of earnings to hours are not the same each week, so the earnings do not vary. There we go, that's it. The ratio isn't the same. 140 over 12 does not equal 170 over 15, which doesn't equal 200 over 18, which doesn't equal 230 over 21. Again, once one of them fails, you don't even have to check the rest. It's not a direct variation. The earnings increase at a steady rate, so the earnings do not vary directly with the hours. Well, that depends. That depends if it goes through the origin or not. This one doesn't. So the earnings don't vary directly, but it doesn't have to do anything with a steady rate. Again, you can have a straight line that doesn't go through the origin that won't vary directly. Straight lines that pass through the origin do vary directly. A veterinarian knows that a 50-pound dog gets 0.5 milligrams of a certain medicine and that the number of milligrams varies directly with the weight of the dog. Okay, so here we go. Let me draw a table. Get that back on there. Here we have the weight of the dog and the number of milligrams. So a 50-pound dog gets 0.5 milligrams. The vet uses these steps to find the amount of medicine to give a 10-pound dog. Okay, so I'm using W and M just as they are. Remember, W is actually X and M is actually Y. So if I write, and I do this a lot for students because we don't know which letter to put in place of what. If we say Y equals KX, now we're going to say M equals KW. Okay, so if we try to calculate K, we're going to take 0.5, that's the Y, over 50, that's the X. This is a really small number. 0.5 divided by 50 is 0.01. So here we're good. Here we're good, right? We're going to write the equation now. M equals 0.01 W. What this means, this constant of proportionality, or I forget what they call it here, constant of variation. If the dog weighed 1 pound, they would get 0.01 milligrams of the medicine. So the constant of variation is the Y value when your X is 1 always. So I could put that other. Now you're just trying to find out what does a 10-pound dog get. And when he substituted it into the equation, substitute 10 into the equation. So 10 is the weight, the pounds of the dog. That's this column here. So they should have substituted this 10 in for W, but you can see here they substituted it in for M. That's the amount of medicine or milligrams that the dog gets. And when you get an answer, like 1,000 milligrams, think about that. A 50-pound dog got 0.5 milligrams. How on earth could a 10-pound dog get 1,000 milligrams? That's way the wrong way. We would expect our answer to be less than 0.5. Some of the mistake came where they substituted incorrectly. They substituted in for the wrong variable. So that was the error there. So again, with constant of variation, the biggest thing is remembering that you're going to take the y value and divide it by the x value. And that's how you find out what the constant of variation is. And it's also how you figure out if relationships are proportional or if relationships vary directly. Those terms are kind of interchangeable. So I'll go ahead and add another retake to this. Let me know if you need any help. I do have some work with proportional relationships that might be helpful also if you need it. Stay in touch. See you soon.